Hello friends, welcome back to our channel. So in today's video, we will be looking at how to run weather research and forecasting model for uh, real data case, wherein we will be running model for a particular time interval, perhaps in July 2024, and I will show you uh, how to set up a domain and how to download various initial condition data set. What are the different things one need to be careful about while running the model, and how to check that model has been ran successfully or not. So we will begin with the documentation of WRF model. So you will be able to uh, download the data by yourself without any trouble. So let's go into the Google and just type WRF compilations. As you type WRF compilation, just click on the first link, WRF compile tutorial, and you will be redirected to the WRF compilation page. So many of you might have already watched our uh, previous videos. So all these pages might be familiar to all of you. So we have done various environmental tests and system environment tests. We have we have built libraries. We have tested compatibility tests, and we have built WRF after doing all this, and then we built the WPS modeling system. Now the next step is the static geography data and real-time data. So these two data set has to be downloaded. And once these two are done, we can run WPS and WRF. So it is just a two-step process. So let's directly go to the static data set. So you get the WRF modeling system is able to create idealized simulation, though in most users are interested in the real data cases. So there are different type of WRF compilation. So whatever I have described in these tutorials or in my channel is the real data case because it is the widely used and has most practical applications. So to initiate such simulation, which is the real data case simulation, the domain's physical location on the globe and the static information for the location must be created. So if you want to learn, for example, if you want to run your model over a particular country, you need to specify its latitude and longitude boundaries, whether it is over ocean, how much fraction is over ocean, how much over the land, what type of topography it is, whether it is mountain, plain, what type of land type it is, whether it is uh, uh, forest land or whether it is desert or what type of land it is. So, and also what type of uh, what type of surface it is, either it is ocean or lake or similar type. So these type of information which usually don't vary over the simulation time are known as static properties or static data. Okay. So this requires a data that's for this or for all these specification in the model. How will model know that these are the properties of that particular area? For that, we need to download a particular data set, which is known as the static data set. So you can just click on this link and you will be able to get whatever type of data set you will want to download. So you need to place it in build WRF directory, which we have already created. So keep in mind that if you are downloading the complete data set, the file is very large. It will be around 30 GB if you expand it. So make sure that if you are on a sharing space on a cluster, you may want to consider placing this in this central location so that everybody can use it. And it's not necessary to download for each person. Or if you are using it on personal computer, then there is no problem as such. So just gunzip it after downloading and untar it, and then move it to the WPS geo location. So you don't need to really go into this because it is already done. The new data set comes in a familiar format. Okay. So once you click on this, there are three options: mandatory data set, static data set for the specific applications, and the optional static data set. So you do not worry about all these things. So if you are running, if you want to run, you can simply download the highest resolution for each mandatory field. So if you want the full capabilities of these fields, you have to download this one. You can also download the lowest resolution for each mandatory field for if you just want to test or run. But I have already downloaded the highest resolution, so I will show you the simulation from using that data set only. Okay, so there are various classes: albedo, green fraction, leaf area fraction, albedo, different type of land use, land cover, orographic variance, soil type, topographic variance, and various different type of properties of land has been specified in these files. Okay, so when you click on this, it download process will start. Okay, so once you download it, you will be able to see different type of. For example, if you go to download section, uh, let me show you size of it, du1sch, and okay, so so the size of it is, this is for low resolution, it will be around 1.43 MB, and for all the mandatory field which are of a high resolution, uh, it would be around, I'm sorry, it would be around 2.6 GB. Okay, so it would be around 2.6 GB. So when you untar it, so how you will untar it? Just use star minus star dot x v z f, and you can use following which you can use this. Or if you are unfamiliar with it, simply first use gunzip, then use star. So these two commands will untar it or untar and unzip it. So you will be able to do that. So once you have this, let me show you. If you when you untar it, so now let me get you to the uh, uh, build directory, and this is the geodata. So you can see here, this is geodata. So we can go inside the geodata, and here it is this one, WPS GEOG. So this is inside this, we have all the expanded version of that, uh, which we have downloaded. Okay. So now what we can, let's go inside this CD WPS. Okay, inside it, and you will be able to see various fields. Okay, albedo, green fraction, all these things, topographic variance, orographic variance, topographic height, soil type, all these land use, land cover, all are available. Now, one thing we have completed, which is very important step. Uh, Now what we have to do is to uh, make sure. Okay, so what we have to do now is to download the initial condition data. So for example, I'm just taking it for a just for an example, for an instance, you can use for other dates. So we are planning to run WRF model for 1 to 2 July 2024. So current date. So this is just recently. So for that we need initial conditions. Okay, so how we will download the initial condition? So there are two type of initial conditions as we have discussed previously. So let me show you how we can actually, okay, to real time data. So it would not be, so just click on this link. So you will be redirected to the main download page. Now from here, go to the input data for WRF. Okay, just click on from download. Last one is input data for WRF. From here, you will have several options. Okay, so these different options are just for the different type of reanalysis data set or different type of models. Some are from, for example, first two are for NSEP reanalysis, GFS at 1 degree. First one is for the 2.5 degree. Okay. Similarly, for the NSEP, other for these are for GFS. So all for all these different type of and a reanalysis, we need different type of V tables. That is the variable tables. So WRF will choose important variable which it needs for the simulation. So these V tables are required for that. For NSEP and NCAR analysis, we need different V table, that is NNRP V table. For other different, for similarly for ECMWF, you need V table for ECMWF, or for similarly for unit for the um, era interim or era 5. Okay, so era 5 or era interim, you need a different type of V table. So just for time being, I am using NSEP final reanalysis data. So let's click on it. You can use any of those, but just for demonstration purpose, I am using this. So go to the data axis. Okay, so there are description of data, wave server holding, different type of servers. So you do not have to worry about. So we have grip 1 from 1990, 2007, and grip 2 from the 2007 to current. Okay, this is the interval. So just we are actually running for the recent period. So our period falls in this block. Let's click on wave file listing. Okay. And we have paste, browse, and complete file list. Let's click on the complete file list. Okay. Okay. So you will have different for different year grip 2 files, 6 hourly. Okay. So just click on 2024. Okay. So it is loading. Okay. So from that, you can just click on this is for January, February, March, April, May, and June, and July. So let's click on July. Now you can download. So either you can click each individually, or you can just click all of them together. Okay, together. Or what you can do, you can use this Python download script. Just click on this, and it will be downloaded. Okay. So once you have downloaded this Python script, then you have to run the Python script. Okay. So let me show you. Okay. There it is. Okay. Has not been downloaded. Let me check. Download Python script. Let's see the history of downloads. Okay, it has been downloaded, but where it is located? Let's locate it. It this one, around 3 a.m. Okay. So if you click on this, it will have Python script. So it will download the different type of FNL file for different time period, different time step. Just run this script. You would be able to. So let me show you. You may be in confusion otherwise. Okay, so let me open it. Okay. Now what you have to do is Python R downloaded stick dot py. I don't know whether it will work or not. Spacing is not good. There is a problem. Let's rename it final. Okay. So once you rename it, you will be able to download final. Okay. So once you click on it, the download process will start on the terminal. So it is done. So I'm just stopping it because I have already downloaded it. So I don't want to, it will be around 30 GB, one file. So you have to check whether the file is, or you have enough space in it. So once you have downloaded it, you are done. Now let's check where I have downloaded it. So just go back the dot cd input data. So I have made the directly input data for input file, geodata for static file. These are the library which we have already installed. This is for the output file, so I'm using it. Okay. cd input data. Okay. Let's see. So I have these files, FNL files from for all of July. So I have downloaded for all of July. You can download for whichever period you want. Okay. Now what we have to do is to run the model. Okay. So we have to do two things. Okay. For running the model. First, we have to set up the domain. Okay. Either you can set up domain directly. Okay. So there are 3-4 type of uh, map projections. I don't want to get into that right now. So let's first of all we have to run the WPS. So let's uh, go back and cd build WPS. Okay, okay, this is the WPS. So I have already ran this model, so I have to remove few files. Okay, sorry. Okay. So okay. Now let's go ls minus. Okay, what it, as you can see, we have geogrid, we have metgrid, and we have ungrib. Okay, so these different things we have. Okay, so first of all, let's open the namelist.wps. Okay. So you have to, let me make it clear so that it will come the top. Okay. So let's open gedit namelist.wps. So this is the uh, most important file for us, which will define various different fields. Okay, so now let's have a brief look on what all this file all about. So first is the share, so which describes the WRF domain, which is the advanced risk WRF. Maximum domain we are using 1. Okay, start date is from 2014, 7/1. This is for uh, hour, minute, and second, and this is the end date. The interval seconds is the 6 hour. That is in the seconds, because the FNL data which we have planned to download is in 6 hours. So it is from 0 to 6 hours. 0, 6, 12, 18, 0, 6, 12, 18. So you have to check what is the interval of your input data. So once you are sure that your input data interval is 6 hour or 3 hour, you can mention in seconds here. Okay. Similarly, what you can do, this is the input output from the geogrid. So what type of output you want from your data. Okay. So, I have already discussed that we have to run 3 type of ls. Let me give you a ls, ls, exe. Okay. So we will be running 3 executable. First, we will run geogrid. What this geogrid will do? Geogrid will make our domain. It will specify latitude, longitudes. It will make mountains. It will specify where is sea in your domain and where is land over your domain. what type of land use, land cover will be over your domain. So all these things will be specified by the geogrid. So once you run the geogrid program, it will make all these it will specify all these properties to your domain. Okay. Then we will be running ungrib. So what ungrib does? Ungrib takes the initial condition, which is in our case the FNL data, and it actually interpolates that input data to the metgrid, geogrid, sorry. So we have geogrid with particular resolution. So you can, for example, you want 5 kilometer, 10 kilometer, or it can be 100 kilometer. So, but input data might be in different resolution. So ungrib extract that data in intermediate format to interpolate on the geogrid file or geogrid resolution or geogrid specified domain. And finally, we will run the metgrid. What it does, it interpolates the intermediate ungrib files onto the geogrid field or geogrid, uh, whatever grid has been created by the geogrid program. So first we will create the grid, topography and everything. Okay. Then we will extract the data uh, from the external uh, agencies, for example, FNL data, and that input initial data will be converted to the intermediate format from the ungrib to the model suitable format, and then that data, intermediate data, will be interpolated to onto the geogrid field through the metgrid program. Okay, so these are the three uh, tasks of these three programs. Okay, so how we will run each model? So before we will run these executable, we have to specify somewhere properties of these things, up to what time we want to run the model, what resolution we want, what type of projection we want, and what type of uh, resolution or uh, we want, how many domains we want, is there it is nesting or without nesting. So all these things has to be told to the model or told to this program, or these all these information which we are planning to which we want to specify to the model are actually written in this name list.wps. Okay, so this is the library and this is the user manual from where the all three programs will extract the information. Okay, so this is the share as we have already discussed. First start date, end date, interval, input and output, and this is the output from geogrid path. So where you want to store the output from the geogrid, this is the directory which you have to specify, or if you do not specify, it will store in the current directory, which is the WRF folder. Now this is for all common. This is the top level information. Now these are the parameters for the geogrid program. Similarly, these are the parameters for the ungrib, and these are for the metgrid. These are the different model levels you want to specify. You can specify, other there is no need to specify. It's just fine, no problem at all. Now, what uh, what is important here, which we have to remember, is first of all, parent ID is 1. Parent and grid ratio 1. I This is the J start 1, J start, I start, J start, and east west number of east west grid point 40, south 40, resolution 10 meter, TX how much resolution you want. So this is around 50 kilometer. This is in meter, so it's around 50 kilometer. How much resolution you want in by coordinate is 50 kilometer. Again, map projection. There are various map projections in the WRF. If you just you need to go to the WRF documentation and you will find out there are 4, 5, 3, 4. If I remember correctly, Mercator, and then we have latitude longitude projection. Then Lambert conformal. Then you might have polar uh, projection. So there are various type of projection you can use for your simulations. So this it looks maybe little difficult for you. So I will show you a very simple way to deal with this. So uh, let me show you a program. Okay, it is not happening. Something. Okay, what happened to this? Okay, so let me uh, horizontally. Okay, WRF to. So okay, so for instance, for now, just assume that these are the parameters we need. You have to define for the Mercator projection, you have to define the reference latitude and reference longitude, true latitude, true longitude, and standard longitude. So these parameters has to be specified. Okay. And then you have to specify the geogrid data path. Where are your geogrid files? So this is the path of our geogrid file. I think you might remember where we have placed this WWF geogrid file. And this is for the table. So where are the table, V table for the WRF? So this is for geogrid. So make sure that this is specified as the geogrid folder. This is the for resolution. So this is for default. So you do not have to worry about. But if you get any errors, then you need to include this line. Otherwise, there is no need to include. Or you may find error while running the geogrid. You may find error that this data set is not available. This file is not available. So you need to manually go to the website and you can download those files. Or you can use whatever resolution available in your current geogrid uh, geodata file download. And then reference F and reference by. Okay, so ungrib file format is WPS, output and prefix is file. It is not very important to worry about. And for metgrid, flag name is file, input output 2 is, it means that it will give output in the netcdf file. If you want to change, you can change, but there is no necessity to change it. Output from the metgrid, so where you want to output of the metgrid, so you can specify where you want. And this is the table, so it is always the metgrid folder. So make sure that it is the WPS metgrid. You have to specify where is your metgrid, so it is in always in WPS folder. Okay, so once it is set, all set, then what do you have to do? You just have to run the geogrid.exe. Okay. Once you start running it, it will process it, and it will show you the successful compilation of geogrid program. Okay. Okay, so let me show you one more thing. uh, on wait. Okay, so let me show you. There are utilities. So if you want to check your domain, whether the domain working for you or not, okay, so you can just run the plot grid dot old dot. Oh, this is, I'm using this and for NCL, so you can just run NCL plot grid old NCL. Okay, so this will show you the WRF domain. So let me show you. Okay, so this is the WRF domain which we are using. So I'm running over the Indian region. So this is the domain which is showing. If you want to change it, you can change. Of course, if you want to change, how you will change? You will simply increase uh, the east-west. Okay, so suppose if you make it 60, and if you make here 60, it will, of course, it will increase in size. Let me save it and close it for the moment, and you will see that now it is covering much more domain. So you can also change the center of it. So for suppose now currently we are using reference long 77. If you change it to, for example, 97, what do you expect? We change the reference longitude, it will shift toward the right side. So suppose if you want Indonesia, it will shift toward the right side. From that center longitude, it will extend the domain half and half number of points. Okay. So if you just run it, it will give you, stop it and see. So now it will covering the Indonesian region. So I will cover in the next different video as to how to select this. But for now, I am just giving you the brief overview as to how to run basic field. And in a separate video, I will show you how to select the model domain and various different type of model domains. Yeah. So this is, let's go back. Okay. Now we have to again go to the WPS. So first we have to run the uh, geogrid. So the geogrid has been run. Now let's check whether our things has been done. So what output folder we have specified for the geogrid part. So geogrid out of to where it is geogrid data path is here, and where is output for the geogrid. Output for the geogrid here. So it is in WPS and tutorial. Okay, WPS out and tutorial. So let's go into this. Let's go into this. This open this, copy this, and TD this one. Okay. Okay. So let's open it. So okay. So once you open it, you will have the file. This is first file. This is the GeoEM. This file, first file. Okay. So if you open it, let's. So it will give various different fields. Okay. So if you open this, you will have latitude at mass coordinate, longitude at mass coordinate, v velocity, u velocity, latitude on u grid. So this is the staggered grid. So it uses c staggered grid. So so these are the staggered points. Okay. So mass fraction, there are various fields. Or this is the Coriolis parameter or land mass. This is for land mass, where are land, where are oceans. And land use, land fraction, land use cover. This is the topographic height, soil temperature, soil level, soil moisture, albedo, green fraction, leaf area index, snow cover, or topographic variance, or variance of the subgrade scale topography. So these are the different fields which this will contain. Now, once this is completed, now the second step is to run the ungrib. So just for running the ungrib, you have to do few things. Okay, so just go to our this one. Go down from here. Okay. Now start from here. Running WRF. Okay. So running WRF. Go to CD. We have already run the geogrid. If you use this one, this command, so there will be a log geogrid. If you open this, you will have the message, various message, whether it has been compiled successfully or not. So you can open this one. You can check whether if there are error or something, you can just track for those things. So now, once if you successfully created the geogrid file for that domain, then you are ready to prepare to run ungrib. So now first we have to link the initial data from where we have downloaded that is the 1 to 2 July. Okay. So how you will do this? Okay. So, okay, let's go to this one. little small, fine. Okay. So now what we have to do? We have to link. Okay. So link. Okay. Okay. So where it is our data, guess. Let's link. Go to the input data, and then we have what's it is geo. This is the FNL. We are just linking all to the current. Make sure that this is the current. Okay, so make sure everything has been done carefully. So we are linking this all the star is for the all the FNL files into the this dot is for the current directory. Okay. Now you will see here the link of all these. So all these file has been linked here. This all these files for all July 2024 grip 2. So now we have all the file linked. Clear it up. Now we have to connect the V table. As we have discussed that we need the GF, we have already downloaded the FNL, GFS FNL data. So we need the GFS table. Okay. So we have to soft link. So this is for soft link V table. So just copy this one, or you can just, if you want, if you prefer, you can type. So what we going to do? ln sf, okay, ungrib V tables, V table, GFS, GFS, and V table. Okay. Once this is done, clear it up. Okay. Now these two things has been done. Now we are all done to run the ungrib program. Just execute the ungrib, ungrib.exe. Okay. So it will take a moment according as per your time. So we are running for these 2024 July 1st to 2nd. So just for sake of to save time, I'm running for just for a short period of time. Okay. So finally, it has been completed. Success compilation of ungrib program. So once it is done, now we have to run the metgrid program. So let's check again. You should have files with prefix file, or if you have named them something else, then you should have that prefix. Okay. So we are using here what file. So ungrib WPS output format and prefix file. So you should be able to see these files. Okay, let us check. Okay, so these are the files. Successful compilation. Okay, now we are ready to run the metgrid. Okay, so either you can run directly or you can also generate the log metgrid file as you wish if you want. So let's run the metgrid.exe. Okay, it will take few moments for each hour it is running. Now it will show the successful compilation of metgrid program. Okay. Now clear it up. So once it is completed, you should have the files with prefix met.em for each period which you are running. Okay. So let's check whether it is true. ls star ls star met. Okay. ls met star. Clear for clarity, just use ls. Okay. So this is for 00, 06, 012, 018, 118, and 200. So this is the from 1 to 200. This is what we have specified, isn't it? This is what 1 to 2. So if you increase this one, you will have more metgrid file according to period you are running the model. Now what we have to do, we are done with the WPS. We have ran geogrid program, we have ungrib program, we have metgrid program. So these three have been completed. No problem at all. Now we are ready to run uh, the WRF. Okay.